Okay, so I think we just start with exit pass 7.1a, the first one. Okay, so over here we are looking for the equation of line passing through these 2 points. So the 2 points are A60 and B08. Okay, so how do we find the equation of a line? We always need a point. We also need a gradient. So 1 point, 1 gradient. So can we find the gradient for this first? So the gradient y2 minus y1, x2 minus x1. Okay, so this will be negative 4 over 3. Okay, so with this gradient over here, you can use y equals to mx plus c, the first method. The second method is to use the shortcut y minus y1 equals to mx minus x1. So that's the second method, and that's what we will normally use in AMath, which is a bit faster than the y equals to mx plus c. But if you don't know how to use this, it is fine. You can always fall back to y equals to mx plus c. Okay? But then the second thing is, can you use the second one in AMath? No, we cannot, because AMath 1 will be strictly in AMath. Okay, we cannot bring over to AMath. I also don't know why, even though it's technically correct. Right? So with this one, how do we use this? So let's say if I want to make use of point A. Okay, so I will need to make use of this one. So y minus y1, m times x minus x1. So let's sub in our point and the gradient. So the point is 60, so 6, 0. The gradient from above is negative 4 over 3. Okay, so the equation that we have, y is equals to negative 4 over 3x plus 8. Okay? Have this? Can Okay, part B. Part B, we have this one over here. Okay, so same thing, gradient, y2 minus y1, so 5 minus 1, x2 minus x1, so 5 minus negative 3. So this thing will be equals to 4 over 8, so a half. Okay, so the equation of the line, y minus y1 equals to mx minus x1. So we fill in the blank, sub in the gradient and the point. So the gradient is half. The point I'm looking at, let me use this one over here. Okay, so this one, let's say if I put 1, the negative 3, I need a bracket negative 3, so you have to be careful with this. So how do we go about this? So y minus 1, half x plus 3 over 2. So y is equals to half x plus 5 over 2. Okay? So do you need to do this long? Technically, don't need. You can start from here. You can go off to the last statement if you can do things faster. You don't have to do step by step. Okay? This is just to show you how it works. But the key steps are just this one and the final one. Okay, good morning. Good morning. Wow. Okay, can. Okay, Okay, for question 2, over here. Alright, so question 2, we are looking for the angle of inclination between the 2 points. So let's take a look at this one first. The first one is a straightforward one. If you're not sure how does it look like, it will be good to visualize it. So you have E and F. So E and F, right? So I have F around here, 1, 4. Okay. Then I have E, which is 2, 9. So somewhere up here. Do you see this? Right? And we can actually put a straight line over here. Okay? And we can draw a line towards the positive x direction. Okay, so what do we mean by angle of inclination? We are looking for this angle over here. Okay, so the angle of inclination that we want is this angle over here between the positive x direction and also this line. Okay, so how do we go about this? Okay, we need to make use of gradient equals to tangent theta. So this theta over here will give us the angle of inclination. Okay, so how are we going to do this? Okay, so first gradient. So what's the gradient over here? y2 minus y1, x2 minus x1. So 2 minus 1. So this is tangent theta, Greek letter T or Greek letter theta. So this one, the gradient is 5, correct? 5. Okay, then how do we look for this angle? We need to do inverse tangent, correct? So over here we bring the tangent to the other side. Inverse tangent of 5 will give us the angle theta. Okay, so what is this value over here? What angle is this? Sorry? Okay, so 78.7 degrees is equals to theta. So this one very straightforward. Okay, this one is quite straightforward. Okay, for B. For B over there, right, you have G and H, 3, 0 and negative 5, 12. So we will do negative 5 and 12 first over here. Okay, and then G will be somewhere over here. 3, 0. Okay, so your line will be somewhere like this. And we also need our positive x direction over here. Okay, so what is the angle of inclination? It is in between this line and also the positive x direction. So this is the angle that we are looking for. Okay, our angle that we want is over here. Okay, but the problem now, right, is that here, let's take a look at the gradient. So gradient is equals to tangent theta. So the gradient is y2 minus y1, so 12 minus 0. The y1 is negative 5 minus 3. Okay, so this is negative 3 over 2, correct? Correct, 3 over 2. Okay, then when you do the, when you do the inverse tangent, okay, when you do the inverse tangent, right, what are we going to do is that we are not going to use the negative gradient. We are going to use the positive number of the gradient. Okay, means we are looking only at the absolute value. So instead of negative 3 over 2, I'm going to look at 3 over 2 first. Okay, equals to theta, the theta that we want. Or actually, this is not mathematically correct, but this is what we want. Okay, in real life we'll be using alpha when we come to the chapter soon. Okay, so what is this number itself? 50 something, is it 50 something degrees? Okay, so 56.3 degrees is equals to this theta. Okay, so now what happened is, where is this 56.3 on this line? The 56.3 degrees is actually over here. Yeah. Correct, but we are only looking at the absolute value first. Okay, I'll explain more when we come to chapter 9. Okay, the trigo chapter. Chapter 10, trigo chapter. Okay, so this is our 56.3 degrees. So what is our angle over here? What do you think is our angle over here? Okay, so the angle that we want is 180 minus of 56.3 degrees. So this is 123.7 degrees. Okay, so this is the first way to answer this. Okay, the second way to answer this is, let's say because what you did, the calculation that you did for this part over here, what you did was, tangent inverse of negative 3 over 2 is equals to the theta over here. Okay, so then over here you get a negative 56.3 degrees equals to theta. Okay, so now angles have actually a positive angle and a negative angle. So with reference to this line over here, if the anti-clockwise is going to be positive, the negative is going to be which direction? The opposite direction, the clockwise direction. So technically speaking, the negative 56.3 degrees is actually over here. If you extend your straight line, the angle that this line makes with this x-axis is going to be a negative 56.3 degrees, this direction. Okay? So now angles being positive and negative, you need to realize that there's a direction for the angles. Okay? So with reference to the x-axis or the positive direction, x direction, the angle that it makes is now negative 56.3 degrees. And because of that, what is the angle of inclination? Also 180 minus away this 56.3. Okay? Can So this is what the negative angle means. It goes opposite direction. Okay? Clear? So technically speaking, if you were to do this, it is also correct, but you need to find the angle over here again. Okay? Can Okay.